Welcome to the screencast of 3.1 Geometry Fundamentals. So the first thing I want to note is we're going to go over some vocab words. So in particular, this chapter, you can see this everywhere all around you, hence why we have a picture of a building. So if I would have, so we said two lines are parallel if they lie on the same plane and do not intersect. So they're on the same plane, right? We have these two lines and they don't intersect. So we could write the above lines as R is parallel to S. So say R is parallel to S, and the symbol is going to be the little two lines parallel to each other. So if I would draw this out, just an example of what you will see as parallel lines, normally we make a little mark on them with these arrows that mean parallel. So we have these arrows, either one could mean parallel. It just shows it's not going to touch. And then two lines are perpendicular if they intersect to form a right angle. So a right angle is 90 degrees. So you'll see a little box like up here. This is the little box that means 90 degrees. We can write perpendicular lines above as S is perpendicular to T. So the symbol is just that upside down T value. Right, just that upside down T where these are actually two lines that are parallel, the symbol for perpendicular, two lines that are perpendicular and crossing. So determine whether lines are parallel, perpendicular, or neither. So lines M and N. So here's N, here's M. So they are parallel because we have the same little arrow pointing in the same direction. P and Q. So if I look, well, let's skip down to N and P. Let's do this one first. So P is the blue, N is the green, and you notice that there's a little symbol right here that means 90 degrees. So these are going to be perpendicular. And then lines P and Q. So P and Q are going to be this guy. So this is Q, this is P. Well, we know they cross. In order to be parallel, you're not supposed to cross. But they're not crossing a 90 degree, right? There's not a little box here that means 90. So we would say neither. They're not parallel because they're crossing, and they're not perpendicular because they're not meeting at a 90 degree angle. All right, let's keep going. Two lines are skew if they do not lie on the same plane. Skew lines never intersect. C and B are skew because one is going through the plane and the other is lying on the plane. So they're not parallel because they're not lying on the same plane. They are not perpendicular. They do not intersect. So not the same plane, not intersecting. Determine whether the lines are skew. So I have F and H. Turns out they're crossing, they intersect right here. So they're not skew because they actually intersect. Skew lines cannot intersect. Okay, what about if I have F and G? So G is behind and then F is in front of it. So they're not crossing. If they were crossing, they would make a little dot on the diagram showing that they intersect, but they're not crossing. So we would say they are skew. All right, fill in the blank with parallel, perpendicular, or skew. Step by step. So line Z and line X. Z is here, X is here, and they meet at a 90 degree angle. So these two lines right here, they meet at 90 degrees. So we'd say they are perpendicular. Line X and line Y. Line X is here, line Y, and they even have the little symbol, the little arrow that means parallel. And then line Z and line Y are skew. They don't cross, they don't intersect, they're not on the same plane. Awesome. Two planes are parallel planes if they do not intersect. So it's kind of like the floor and the ceiling of your house. Right? They don't intersect versus a wall in your ceiling would be intersecting. A line perpendicular to a plane is a line that intersects the plane at a point that is perpendicular to every line in the plane that intersects it. So I think in class I talked about how there's the four corners. So Utah, Colorado, New Mexico, Arizona, There's like this flagpole right here that comes straight out of the ground, a little flagpole. Well, that flagpole is perpendicular to the state lines because all the state lines intersect right there at the four corners. So it would be perpendicular to all of those. Alright, refer to the diagram to answer the following questions. Name a plane that appears parallel to plane B. So if this is plane B, the plane that would be parallel is plane C, because it doesn't look like they're going to be crossing. Alright, you can see that line L is perpendicular to B, and line L is perpendicular to C, and since they are both perpendicular to L, therefore they must be parallel to each other. Name a line that appears perpendicular to plane B. Okay, we need a line that's perpendicular, and so that would be line L. So you have to read the directions. If it said plane that's perpendicular, we'd say D, but it says line. Think of each segment of the diagram below as part of a line. There may be more than one correct answer. Name a line that's skew to VW. So if this is VW, I need to highlight all the lines that would be that would either be on the same plane or intersecting. So all of those lines would be intersecting. Well, technically, QT could be parallel to VW if we would make a plane that goes across there. So I want it so that they definitely are on separate planes. Okay. So I have QR, QU, ST, and SX. These four lines, well, here are their segments, but we're assuming each segment is part of a line. Those four lines would be skewed to VW. So QR, QU, ST, and TX. Alright, name a plane that appears parallel. Let's erase all this. So name a plane that appears parallel to plane VWX. VWX, okay, so that's this plane. What would be parallel is this one that's across from it. So you could name this a couple different ways. We could say plane QRS. We could say plane STQ. Right, you just need 3 of those letters to name the plane. And then we want a line that is perpendicular to this plane that I highlighted. So perpendicular would be these 4 because they would meet at a 90-degree angle. And of course you only need 1. That's why I'm listing out all the correct answers, because you only need 1. VR, UQ, SW, and TX. Alright, solve each inequality, then graph its solution. So first step, add 3 on both sides. We get x is less than 1. So this arrow, right, this inequality, as long as your variable's on the left side, the arrow will show you which way you're going. So let's see, we have 1, an open circle, and the arrow's going that way. So if it's a less than or greater than symbol, it's an open circle. Less than equal to, greater than equal to, it's a closed circle. Okay, let's try the next one. Let's add 8, subtract 2x, we have 2x is greater than 8, so x is greater than or equal to 4. So I have a closed circle at 4, and the arrow is going to go to the right. Alright, here's a little more difficult one. When we divide by a negative number, you flip which direction your inequality is going. Divide or multiply by the same number on both sides, and you're going to flip which direction your inequality is going. Alright, order of operations. X over negative 3 is less than 2. So multiply both sides by negative 3. X is greater than or equal to negative 6. Because we multiplied by negative 3 on both sides, we need to flip the direction of the inequality. So I go to negative 6, make a closed circle, and my arrow goes that way. So that's it for the first lesson.